Section 5 is a super short section. There's no algebra. It's all just interpreting graphs. And I don't know that I do the best job with this interpretation. And so let me start off with some warm-up before we get into the section. First of all, I would say in this section we're going to be focusing on the y-coordinates of points or of graphs. And there's just a simple few things that we need to understand about y-coordinates of points. First of all, any point on the x-axis has a y-coordinate of 0. I graphed just some generic points, and I graphed 3 points on the x-axis. Here's my x-axis. There are the 3 points, and it's not a coincidence that each one of those points has a y equal to 0. And in this section, unfortunately, we're going to use function notation as opposed to x-y notation. So instead of saying each coordinate on the x-axis has y equal to 0, we're going to use the function equivalent, and we'll say each point on the x-axis has f of x equal to 0. We're going to use f of x and y's interchangeably, and really we're going to use y's in this section. So that's one of 3 concepts that we need to have understood. The other concepts have to do with regions as opposed to just the axes. So I'll say any point above the x-axis has a y-coordinate that is strictly positive, or that is greater than 0. Because if a point is above the x-axis, its y can't be 0. They have to be on the x-axis for its y to be 0. And so any point above the x-axis, so first we have on the x-axis, and you have the y's equal to 0. Any point above the x-axis has y's greater than 0, and function notation wise, I'm going to say it's f of x is greater than 0. And let me show you on the graph what I mean. So if I just look at the points above the x-axis, I only marked 3 of them, but the 3 points that I drew, the point -6, +5, it had y equal to 5, which is bigger than 0. The point 0.8, it has y equal to 8, which is bigger than 0. The point 3.7, which has y equal to 7, which is greater than 0. Of course, in this section, I'd have to say this point has f of -6 equal to 5, using the function notation to describe the point rather than just the xy notation. On this point right here, I would say it has f of 0 equal to 8. And this point here, f of 3 equal to 7. Regardless of what point I pick, whether I use function notation or y notation, any point above the x-axis, its y is strictly positive. It doesn't matter what its x is. Its x could be negative, its x could be 0, its x could be positive. There's no restrictions on the x's on the points above the x-axis, but there is a restriction or something all the y's have in common, and all the y's have the same thing in common, that the y value is bigger than 0. And the last concept we need is for the points beneath the x-axis. And that is any point physically beneath the x-axis has a y-coordinate that is negative. In this section, we're going to have to use f of x instead of y. So symbolically, I would say any point beneath the x-axis has f of x less than 0. So beneath the x-axis, we have f of x is less than 0. And I tried to show that on my graph. I just randomly picked a couple points, and of the points that I picked, it doesn't matter the sign of the x, that doesn't impact the sign of the y. This point has y equal to -4. If I want to describe this point using function notation, I might say f of -3 equals -4. Here the x is negative and the y is negative. This point has y equal to -6. If I try to describe this point in function notation, I'd probably say f of 0 equals -6. So that here's the x is negative, the y is negative, the x is positive, the y is negative. The x is 0 and the y is negative. And in this point, the x is positive and the y is negative. Any point beneath the x-axis, there's no restriction on the signs of the x's, but there are restrictions on the signs of the y's. So we're going to have to really focus on understanding the graphs in terms of the y's. So on the x-axis, every point on the x-axis, we're going to say it's f of x equal to 0. Any point beneath the x-axis, not including the x-axis, I'm going to say it's f of x is less than 0. And any point above the x-axis, not including the x-axis, I'm going to say f of x is greater than 0. This is the key to understanding the problems in this section, that any point or portion of a graph that's above the x-axis has positive y's, and we'll say for that region the f of x's are greater than 0. Any region of a graph or any point on the x-axis has y's or f of x equal to 0, and a portion of a graph or points beneath the x-axis, any portion of a graph beneath the x-axis or any points beneath the x-axis, we need to say f of x is less than 0. With that, maybe this will be doable, maybe it won't. I just don't think I give like the most awesome lectures in this chapter, this section. So problems 1 through 8, and there's only 8 problems in this section, so we're just going to do 4. Give us graphs, either of parabolas or graphs of fractions, and they ask us to answer 8 function questions about those. So for 2a, it gives me a graph of f of x. It even gives me the equation. And problem 2a asks me first to find f of x equal to 0. This is asking me to find the x coordinates of all points that have a y equal to 0, and that's just going to be x equal to -5 and x equal to +2. Those are the 2 points where f of x, which is y, equal to 0. So my answer to part A, that's the easy part. That's the part where I can lecture okay on. Just going to give y coordinates or intervals that describe, I'm just going to give x's that describe the y. And notice my answers are x equal -5 and x equal to 2 because those correspond to the y's equal 0s. So each of my answers in this section is going to be in terms of the x's that fit the y's that are described. Part B of number 2 wants me to find all the points that have y's that are positive. So I need to actually find, for this, I need to find the interval, possibly intervals, which have positive y's. And you only get positive y's when you're above the x-axis. So in order to do the problems in this section, I need to segment the graph into regions. And instead of going at the max or the minimum point, I'm going to segment the graph into regions separated by the x-intercepts. So there's going to be 3 regions, kind of like we do with increasing and decreasing, but using different points because these points separate where the y's are 0 from where the y's are negative from when the y's are positive. I'm creating 3 intervals, which I'm going to do with all parentheses. The first interval I'm going to describe as negative infinity, the far left edge of the x-axis, to negative 5, the x-coordinate of the first point that has y equal to 0. The middle interval I'm going to describe as negative 5 to positive 2, the x-coordinate of the first point that has y equal to 0, comma, the x-coordinate of the last point that has y equal to 0, and then 2 to infinity, which is going to be the x-coordinate of the last point that has y equal to 0, all the way out to the edge of the x-axis. So these are the intervals that are candidates for the answer to 2b. I need to pick the intervals that have positive x's, or positive y should I say, and that's why I did this. Any point or region of the graph that's above the x-axis is going to satisfy f of x equal to 0. So my answer to problem 2b is going to be this region and this region, specifically because the graph that's shown in those regions is above the x-axis, and if a graph is above the x-axis, it has positive y's, or its y's are bigger than 0. So my answer to 2b, the regions that are going to have positive y's are the intervals from negative infinity to negative 5, union the interval from 2 to infinity. Because those 2 regions are above the x-axis, and every point's above the x-axis means all the y's are positive. The last business that I need to worry about before I start getting a slightly new concept is the answer to part C, where the f of x is less than 0. This is the intervals. In this case, it's just going to be interval. That the points have y's which are negative. And it's the region that I haven't looked at yet, because when I look at my Cartesian coordinate system, points on the x-axis have y's that are 0, points above the x-axis have y's that are bigger than 0, points beneath the x-axis have y's less than 0. This is asking me for y's less than 0, so the interval that I'm going to pull off for part C is that interval, and that's the interval from negative 5 to positive 2. Part D and part E are basically asking the same questions as B and C, but they want me to also include the points that have y's equal to 0. So when I go to do part D, when it says find the points that have y's greater than 0, that's all those points, and then add to it the points that have y's equal to 0. This is the or equal to part. So this is saying include in the answer to part D any point that has a y greater than 0, which are all those, the interval from negative infinity to negative 5, and the interval from 2 to infinity, which is kind of written clumsily because I was thinking I was writing something else. And then also include any points that have y's that are 0, and the x-coordinates of those points are negative 5 and negative 2. How I get this answer is I just close up these round brackets and make them square brackets. Here, these intervals mean every point above the x-axis, but not including the points on the x-axis. If I just take the non-infinities and square up the brackets, that includes the x-intercept. So this includes all the points above the x-axis and the point on the x-axis, whereas this interval only includes the points above the x-axis, doesn't include the point on the x-axis. I'll do the same thing for the second interval, close it up, get the interval from 2 to infinity. This interval only includes the points above the x-axis, the points that are strictly greater than 0. When I square up the bracket, it includes all the points above the x-axis plus the point on the x-axis. So all I have to do is just square up my round parentheses that aren't on infinities to answer the or equal to's. So for 2e, to find the intervals where the x's are either less than 0 or equal to 0, I'm just going to take these brackets right here and square them up. This includes all the points that have negative x's, but it doesn't include the points that have x's equal to 0. If I square up those brackets, then it includes all the points beneath the x-axis here, along with the points on the x-axis. So I just square up the brackets to answer the or equal to's. So 4 is an upside down parabola, but it's asking the same questions. Part A, for 4a, find where f of x equals to 0. For B, find where f of x is greater than 0. For C, find where f of x is less than 0. And then kind of the twin of 4b, which would be 4d, find where f of x is greater than or equal to 0. And kind of the twin of 4c, which is 4e, find where f of x is less than or equal to 0. I start off answering the part A's. I find not intervals, but just the x coordinates of points that have y's equal to 0. And it's the same x equal negative 5 and x equal positive 2. To answer the next questions, I need to separate the graph into pieces separated by the x-intercepts, because a parabola can only jump the x-axis at an x-intercept. So my left region is going to be the same negative infinity to negative 5. And because this portion of the graph is beneath the x-axis, this region is going to be a solution to f of x is less than 0, because the graph is beneath the x-axis. Portions of the graph on the x-axis solve f of x equal to 0. Regions of the graph beneath the x-axis solve f of x is less than 0. Regions of the graph above the x-axis solve f of x is greater than 0. My middle interval, again, is going to go from negative 5 to positive 2. And this middle interval, because the graph is above the x-axis, is going to be a solution to f of x is greater than 0. My last interval picks up at x equal to 2, goes off to infinity, and because the graph in this interval is beneath the x-axis, this interval is going to be a solution to f of x is less than 0, because beneath the x-axis you have negative y's, above the x-axis you have positive y's, on the x-axis you have y equal to 0. So for my answer to part B, I'm just going to use the interval from negative infinity to 2, double round parentheses, so I'm not including the points on the x-axis. For part C, I'm doing the outside intervals, negative infinity to negative 5, union 2 to infinity. And then for D and E, I need to include the x-intercepts by squaring up the brackets. These only include the points above the x-axis, not the points on the x-axis, or the points below the x-axis, not the points on the x-axis. To include the points on the x-axis, which problem D wants me to do, I need to square up any value of x that corresponds to a point on the x-axis. And since both -5 and 2 are points on the x-axis, they satisfy the equal to 0 part. And the infinities will always forever get round brackets. Two more, and they're the fraction ones, which are a little bit harder. So in question 5 and 6, I'm given a graph of a fraction. I'm supposed to answer the same questions. So for 6a, I'm trying to find the regions of the graph or the points on the graph that have a y equal to 0. And there's only one point. It's the point -4, 0. My answer to part A is going to be x equal to -4. When I go to do parts B, C, D, and E, B where f of x is greater than 0, C where f of x is less than 0, D where f of x is greater than or equal to 0, and E where f of x is less than or equal to 0. I need to create intervals, and it's a little bit different creating intervals with a fraction than it is with a parabola. The intervals I'm going to create are similar, but one slight difference. So I'm definitely going to create an interval through the x-intercept, but also I need to create an interval that's on the asymptote. That asymptote at, there'd be an asymptote at x equal to 3 here. This graph will get closer and closer and closer to these asymptotes as it goes up. For what that's worth, we learned how to graph fractions in, I guess, the last section. So let me create my intervals. My intervals are here from -infinity to -4. And I look at the graph, it's just barely above the x-axis. So for this interval, from -infinity to -4, this interval is going to be a solution to f of x is bigger than 0 because the graph is above the x-axis. It's barely above the x-axis, but it's above the x-axis, so the y's are positive. My middle interval is going to go from the x-intercept to the vertical asymptote, and you can see the vertical asymptote is at 3. So the middle interval goes from -4 to 3, and all the graph is beneath the x-axis in this interval. So this interval is going to be a solution to the negative y's, which are y's that are less than 0. My last interval is going to go from 3 to infinity, the x-coordinate of the vertical asymptote, to the end of the graph. And this graph is above the x-axis, so this portion is a solution to f of x is greater than 0. So for answer to part B, it's going to be the outside intervals, the interval from -infinity to -4, double round bracket, and the interval from 3 to infinity, double round bracket, because I'm not including the x-intercept. For part C, the interval is going to be -4 to +3. There's an evil trick when it comes to answering the or equal to part. What I need to do is close off any point any value of x that has a y equal to 0 to answer the or equal to part. And there is no point 30 on this graph, so I'm not going to square bracket the 3 because there's no point 30. And when I'm asking find the points that have y values that are greater than 0, I already have those, or equal to 0. I can only add the point that has a y equal to 0. I will square bracket the -4 because it has a y of 0. So when I go to do part D, I'm going to square up the appropriate parts of the answer to part B because these are kind of twins. They both are focusing on the regions that are greater than 0. And then in part D, I need to square up any point where the y is equal to 0. And that's only on the -4, and it's not on the 3. Similarly, C and E basically have the same answer, except for E, I need to square up any value of x that has a y equal to 0, and I'm only going to square up the -4. I'm not going to square up the 3, because the 3, there's no point 30. One last problem. And I'm going to break up the graph after I answer part A. So for 8a, to answer the f of x equal to 0, it's just going to be x equal to 2, the only point on the graph that has an x-coordinate of 2. And then for 8b, I need to find the intervals with round parentheses where the graph is above the x-axis. For 8c, I need to find the intervals with round parentheses where the graph is beneath the x-axis. To do that, I separate the graph into regions. The region to the left and right of the vertical asymptote, and the region to the left and the right of the x-intercept. So I'm going to get 3 regions again. The left region is going to go from -infinity, and not that that's that viewable, but you can tell the vertical asymptote is going to be at x equal to -4, because if I said x plus 4 equal to 0, I'd get x equal to -4. And this region, because the graph is beneath the x-axis, is going to be a solution to f of x is less than 0. So it's going to be part of my answer to C. The middle region is going to go from the x-coordinate of the vertical asymptote to the x-coordinate of the x-intercept, so -4 to 2, and it's going to be a solution to f of x is greater than 0 because the graph is above the x-axis in that region. So part of, at least, the answer to part B is that interval. The last interval is going to go from 2 to infinity, the x-coordinate of the x-intercept, all the way up for the rest of the graph. And even though the graph isn't very much below the x-axis, it's below the x-axis. So for this region of the graph, the y's are negative. And this region is going to be a solution to f of x is less than 0. So in my answer, I'm going to put that into my less than answer. And then for part D and E, I'm just squaring up. So for part D, I'm trying to find where f of x is greater than or equal to 0. I'm going to take this interval, which should have a -4 and not a +4 there, and square up any points that have a y equal to 0, leave round any points, any values of x that don't correspond to a y equal to 0. I'm not going to square up the -4 because there's no point 40. I am going to square up the 2 because there's a point 20. So I'm just going to take this interval. I'm going to leave the -4 with a round bracket because there isn't a point -40. I'm going to square up the bracket on the 2 because there is a point 20. Lastly, when I go to do 8e, it's basically the same answer as C. But I need to get the right brackets on the numbers. The -4 is going to remain round bracket because there's no point -40. The +2 is going to get a square bracket because there is a point 20. And that's the entire section. These can be done using algebra. I was told to cover this section very lightly, so this is a light lecture like they asked me to do. Hopefully you understand the concepts. That's really what I'm really concerned with here, that you understand the concepts of the intervals where f of x is greater than 0, equal to 0, and less than 0. And then the algebra, I don't really think you get this kind of algebra so much in calculus, so it's not the most important, but understanding the graphs is a big, important-ish.